Bismillahirrahmanirrahim. Assalamu alaikum. My name is Professor Dr. Rizwan Jamil Qureshi. Welcome to the new lecture of Advanced Object and Software Engineering, and we are starting chapter number 2, Fundamentals of Components. What's a high-level definition of a component? A component is a unit of composition with well-defined interface for interaction with other components and explicit dependencies to integrate with other components. That means a component has an interface, and that is external interface to interact with other components. And we already covered the definition of interface, that point of contact between user and computer, that's for the user. And there is another definition, which is the high level definition, that interface is a connecting link at a shared boundary, permitting or allowing independent components to meet and act on user commands. So independent systems or independent components, and there is a well-defined interface, and there is explicit dependencies. For example, we have architectural dependencies. For example, we have protocol dependencies, language dependencies, operating system dependencies, and there are specification dependencies available. And we have to cope with these dependencies. We also call them constraints, and we have integration constraints when we want to integrate one component with another component. So whenever we want to use a component, we have to cover that there should be an interface, and there should be an interface, and there should be dependencies there, and we have to cope with these dependencies, with these constraints, to integrate one component with other components so that they can intercommunicate with each other. What are the main attributes of a component? That's the next topic. Component is a unit of independent production, deployment, and maintenance. So it's a unit. We can independently develop it, independently deploy it, and independently maintain it. And then we can replace it with the new component. Whenever we have new component, we can replace the old component with the new component upgradability. A unit of reuse. So it should be reusable, write once, run anywhere in the life of software company. It's a unit of composition. So it's an arrangement, and a component could have several subcomponents. So unit of independent production, you can independently develop it, independently deploy it, ship it, and integrate it and maintain it, easily replace it. Upgradation, update and upgrade should be easy, and it should be easy to reuse, and it should have arrangement. It should be a collection of subcomponents. That's the first consideration regarding the main attribute of a component. Another attribute, it's a package of cohesive services that is self-contained. Here we have a concept of independency. It should be able to perform its functionality independently. Here we have a concept of coupling and cohesion. Coupling means dependency, and cohesion means independency. So what's a coupling? When two or more modules are dependent on each other to perform their functionality, that's called coupling. We have several types of coupling: data coupling, stamp coupling, and cohesion is independence. Mean a module can perform its functionality independently, or a component can perform its functionality independently without the help of any other component. So self-contained means it should be highly cohesive. and it should be less coupled. So whenever we ask programmer to develop a component, we always ask him that it should be highly cohesive and it should be less coupled. We cannot have 100% cohesion. So there is always ratio between them, between coupling and cohesion, like 90% cohesion, 10% coupling, 80% cohesion, 20% coupling, 70% cohesion, 30% coupling. We cannot have 100% cohesion. Why? What do you think about that? The reason is it should be a commercial system. It should be an application so user can easily access that component, and it should have to integrate with other components or other systems. We have integrated systems now. Data entered in one, accessible to all, and vice versa. If it is 100% cohesive component, then it will be a solo component. So we are not dealing with NASA project or FBI or CIA project. It's a commercial project, commercial system, commercial component, and it should be able to reuse. It should be able to integrate with other components, with other systems. It should be able to reuse in other applications, in other projects. So we can't have 100% cohesion. And we also want to have some coupling because we want to integrate it with other components. But we don't want more coupling, more dependency. For example, if a component it has 50% coupling, that means we have to, when we want to reuse, we have to do customization. And if we want to have more customization, like 50% or plus, then it's better to rewrite that component from scratch, line one. So that's the reason we always recommend the programmer, instruct the programmer or developer to develop a component that is highly cohesive but less coupled, not have high coupling and less cohesion. Secondly, encapsulate design decisions. It should contain abstraction. So from the user point of view, it should be abstracted, or from programmer point of view, it should be abstracted when he wants to be used, like framework, like system, operating system, or ATM system, or Amazon, or Upshur, or Nadra in Pakistan. It's not problem of the programmer or the user how that component is developed, how that framework is developed, like VStudio.net or NetBeans or Cake PHP, Zen PHP, or WAMP server, or Microsoft Internet Information Server, or Apache server. It is not his problem how the Windows is developed, or Unix is developed, Linux is developed, Mac is developed, or you are using mobile phone, iPhone, Samsung, how the Android is working, how the iPhone operating system is working. It's not the problem of the user, or it's not the problem of the programmer who is dealing with the NetBeans or the VStudio.net or Cake PHP or Ruby on Rails or Kotlin or Unity. He must know how to use that component, how to use that framework. So it hides design decisions. It's abstracted to reduce the complexity from the programmer or from the user. So abstraction is there. Explicit dependencies, as I just covered a few minutes before, it has constraints, integration constraints, like language, programming languages are different, operating system are different, protocols are different, specifications are different, like MADA in Saudi Arabia, the ATM network. Whenever a new bank like Grindlays Bank or Citibank or Standard Chartered Bank want to operate in Saudi Arabia, these banks have to introduce their ATM system. And this ATM system of Standard Chartered Bank or Gridless Bank should integrate with MADA, with the existing network, with the existing protocols, with the existing specifications, and each bank has different ATM system, but they all are agreed on common protocol, common specification. So we have to deal with constraints, and these are the integration constraints to import the data and export the data. Component is always generic. We try to develop a generic component like NetBeans or Visual Studio.NET or Ruby on Rails. Then it is configurable. We can customize it according to requirements of the customer. That's the concept of component as a generic. It should be loosely coupled. It should have high cohesion. It should have minimum dependencies, but there are dependencies, you have to deal with them. And there is always abstraction and self-contained. It should be able to perform its functionality independently. Like, for example, inbox and send message. The send message module is highly dependent on the new message or compose message in Hotmail, Yahoo, Gmail. You have new message or compose message. As many mails you will send from the new message or compose message, you can see in the send message folder. So send message folder is highly dependent on the compose or new message module component. Output of one becomes the input of the second. Whereas if you compare send message with the inbox, it is highly cohesive. It only needs to log on, like in your mobile. Once you log on, you don't need to log on again and again. As new message will come, it will pop up you, it will show you. That is the concept, that it should be able to perform its functionality independently. So these are the few basic concepts regarding the attributes or properties of component. Then what are main characteristics of component? Characteristics mean the behaviors of component. So the attributes are lazim. It is always there. Behaviors may vary from component to component. We also call them characteristics. There are 9 characteristics of component. Component contains objects, and we already have discussion about objects in the previous videos. That object is a combination of data and methods into a single entity that is uniquely identifiable. For example, student is an object. It has data and it has methods. Data means student ID, student name, father name, mother name, contact, address. Whereas if you compare about the methods, actions, behaviors, it can have eating, sleeping, thinking, walking. So these all are behavior, actions and reactions of student. Employee. Employee is an object. It has data, it has methods. Employee ID, employee name, employee contact, employee department, department ID, department name. Whereas its methods, the functions, roles of that employee. Like, for example, I'm an employee of King Abdullah University. My role is teaching, supervising students, advisor, or supervisor for undergraduate projects, postgraduate projects, administrative duties. These are my behaviors. So that's the concept, that each component is a collection of objects. It has objects like human being is a component, and it is collection of objects like we have heart, liver, kidney, brain, and so on. There are etc., etc. So there are several objects inside the human body. Car. Car is component. It has several objects, like it has gearbox, it has brake system, engine, battery, tire system, and so on. So that is first characteristic of a component. It is a collection of objects. Secondly, interrelated objects. Objects are integrated with each other so they can have interoperability. They intercommunicate with each other. They work as part of that system. There are different parts and they work together so the component can perform its functionality like a human being. If heart system is not working, or liver is not working, kidney is not working, brain is not working, he cannot perform its functionality. Same like car. If battery system is not working, engine is not working, gearbox is not working, can we drive a car? No. So they are ATM. ATM is a collection of objects. For example, it has card reader, it has interface, the screen, it has accounts, it has cash dispenser, and there are several components. And then it is integrated with other ATM systems as one link system in Pakistan or Nadra or Abshar, collection of several subsystems. So we have ATM network and it's a collection of objects and they are interrelated and they are integrated, and then we can use them. We can use any of the ATM machine. If we have account in one of the banks, like I'm account holder of SNB, I can go to any ATM machine and I can withdraw money or I can transfer cash, I can check balance, I can pay bill. That's the concept of interrelated objects. Objects always intercommunicate with each other. Then the component can perform its functionality. A component has interface. Interface can be internal, can be external. Internal, so the components can integrate with each other, components can intercommunicate with each other, so we can have interoperability. And external, so we can have interaction with the user, so user can interact with the system. So internal interface, within that ATM network, components have internal interface and external interface, one for the user, one for the other system. And there is an import interface and there is an export interface. Import interface, when component needs data from another component, we have import interface. When a component provides data, then there is an export interface. So we have categories of interfaces: internal interfaces, external interfaces. Then you have types of interfaces: import interface and export interface. Then you have boundary. There is always boundary. Boundary is a segregation or separation between inside and outside of a component. For example, I'm in the classroom. It has a boundary, and classroom is a collection of objects. I'm present, you are present as students or as a viewers, then chairs, then table, projector, computer, marker, walls, inside, lights. It's a collection of objects and it works as one system. So there is a boundary that separates one classroom from another. Similarly, in the human body, each system has a boundary. Heart system, then there's a boundary, liver system, kidney system, brain system, and then in the car, gearbox, engine, battery, cooling system, heating system, GPS services, tire system, and so on. So there are several components, but there is a boundary that segregates between inside and outside of a component, where one component finished, other component starts. Same applies to the system, where one system ends and other system starts. Like we have transaction system, inventory system, payroll system. There is a boundary where the transaction system ends, like point of sale system, and then there is inventory system. There is a boundary where point of sale system ends and inventory system starts. Constraints are limitations, like integration constraints are there. I just covered protocol, language, operating system, specification, architectural dependencies are there. Then purpose. We always develop a component or system with some specific purpose, objective, goals like transaction, inventory, payroll, attendance, customer relationship management system, supply chain management system, logistics support system, HR system, office management system. So one system ends, other system starts. One component, like in ATM, we have accounts, then you have cash dispenser, then you have card reader system, then there is a database, and then there is an interface. So there are several components, and their objective is to have ATM system. So we develop a component like to deal with the accounts, to deal with the interface, to deal with the card reading, to integrate with other component, to communicate with other component. So each component has specific purpose, like heart system is to pump the blood in the human body, or the gearbox is to change the gears from 1, 2, 3, 4, 5, or reverse gear is there. Clutch has several is specific objective purpose. So each system has specific purpose, or each component has a specific purpose. We develop a system with specific purpose or functionality. Environment. Every component or system has an environment where that system has to work. So external of that system is the environment. For example, we have office environment with where we have other users like our colleagues or our management, our bosses. We have that environment. It is office environment. And then there is external environment, like for the user in the mobile interfaces, it's environment, external environment. ATM system is external environment where users are not available. Your colleagues are not available. It should be more user friendly as compared to the office environment system. And then we have human body. Human body has an environment like our external interface. When we have the skin, outside of skin is the environment where our system finished and other component or other system starts. So that's the environment where system has to work, like ATM network, MADA, Standard Chartered Bank, Gradeless Bank. When they want to introduce the ATM system, the existing MADA is available, and it has to work with this ATM network. That is their environment. That Standard Chartered Bank has an environment of Gradeless Bank, or for example, SNB, Bank of Riyadh, Arab National Bank. Input. Every component has an input and output. It's like process of data flow diagram, that every process has an input. It is not possible that process has input and no output, and there is output and there is no input. Same, a component has an input and it must have an output. It is not possible that component has input and there is no output. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.